Being here from the comfort of my kitchen. In today's video, we're going to talk about a nova, a new star, or what appears to be a new star in the sky, as well as magnitude, how bright things are in the sky. We have talked before on this channel about supernovas and what will happen to a star like our sun at the end of its life, which isn't any kind of nova. We're going to push pretty far through the night here, looking at the city sky in Cork as we come up to the end of April. The nova that we're going to be looking for, it should happen by September, but novae are hard to predict, even recurrent novae like the one that we are going to be taking a look at. Supernovas generally don't recur. Usually when a star explodes at the end of its life, it's not going to, we're not going to see it again. A star can usually just explode once. Some supernovae can happen after a star explodes if its old core is able to build up enough new material, but usually a supernova is the massive release of energy when a huge star much larger than our sun collapses. We're looking into the in towards the Summer Triangle here, in towards Lyra, to look for the Ring Nebula, which will be easier to find in the countryside. There we go. I've gotten rid of the atmosphere, which also gets rid of the light pollution. This is the Ring Nebula, and this is a planetary nebula. A smaller star like our sun, and even stars quite a bit larger than our sun, up to about 7 or 8 times bigger. When they reach the end of their lives, they swell up into red giants. Our yellow dwarf will turn into a red giant, and its outer layer will eventually get blown away as the inner part of the star starts to fuse different elements and become a little unstable. So we get something like this, which happens quite peacefully. Compared to a supernova, this is a very gradual release of material into space, a shell being blown outwards by the energy of the star. If we take a look back towards Cassiopeia over here, there is a supernova remnant called Cassiopeia Alpha, which looks nice and messy. It preserves some of the energy, that kind of energetic look that we would expect with the collapse of a massive star. Now, we are looking into the Milky Way here. There are a lot of things in Cassiopeia. Luckily, Stellarium has a search function, which I will be making use of quite a bit in this particular video. I've searched for it before. There it is, Cassiopeia A. And if we take a closer look, this is a supernova remnant. So we can see all of these different colors blown away to the side. When stars that are much more massive than our sun, more than 8 times more massive, 10 or 20 times more massive, when stars that big reach the end of their lives, the outer layer that's been puffed up, it collapses back in. And that collapse, it generates a lot of energy, it fuses new elements together, and the energy of that explosion, it blows away all of this material into space, but it also generates a lot of light. Supernovas are brighter. A supernova and a nova are just 2 occasions when something in the sky gets brighter. It comes from the word nova, meaning new, because it looks like a new star has entered into the sky. We're going to be looking for a new star in the constellation of Coronae Borealis. Corona meaning the crown, just like the crown of the sun, the corona that we get to see during an eclipse. And I hope some of you got to see the solar eclipse, the total solar eclipse that was visible across North America on the 8th of April, a little earlier this month. The Coronae Borealis is a constellation that we mostly see here in the north. That's why it's Borealis. Up here on the boreal side, we have the Aurora Borealis, and down south they have the Aurora Australis. We're looking at the city sky here. We'll push a little bit later, just about midnight, and we're able to see quite a few stars. The moon is in the sky. The number of stars that we can see here are the ones that are of a high enough magnitude to be visible in the city. The brightest stars have the smallest number. So if we grab Procyon here, its magnitude is 0.4, very close to 0, which makes it quite a bright star. In fact, if we pull back a little bit here to get Sirius back in the sky, there we go. Sirius, definitely brighter than Procyon there. Sirius is a minus 1.45. So it is brighter than the sort of 0 point. The smaller the number, or the bigger the negative number, lower on the number line, the brighter the object is going to appear. I'll see if I get a magnitude here for the moon. The magnitude is -9. So that is a very, very low number, a big negative number. And that's what gives it, that indicates that it's very, very bright. Much brighter than the small negative number here, -1.45. If we take a look around the sky here, we are looking for a very particular constellation. I'll bring us back to about midnight. The constellation Corona Borealis is a pretty faint one. It's tough to see, especially from here in the city. But there are some little guides, little tricks and associations you can use when we're looking at the sky. If we take a look up here at the plough, so either turn around to the north or lean way back, maybe lie on your back and look straight up into the sky. The plough or the Big Dipper is nice and high here in April, and it'll stay nice and high close to midnight for another few weeks. The handle of the plough or Big Dipper has a curve to it, an arc. If you follow that arc, you will arc to Arcturus. Arcturus is a nice bright star. It's also got a negative value, or a nearly negative value at 0.15 there, an absolute magnitude of a negative number at 0.11. So this is quite a bright star. Arcturus is nice and clear, nice and bright in the sky. It's part of the constellation Boötes or Boötes, a bit of a tricky name. If I bring up my name, you'll get to see it. There we go. You have to pronounce those two O's separately, not just one long Boötes. It's Boötes or Boötes. Very tricky one to pronounce, someone who's not used to it, and that includes me. If we find Arcturus, it is a very bright star, even if it isn't in a very famous constellation. You can see it's pretty much level with Leo over here. Leo leads down into Virgo, with this star Spica or Spica being the brightest in Virgo. If you use the handle of the plough to arc to Arcturus, you can spike onto Spica, and that'll help you find that star. So that's the brightest star in the constellation of Virgo. The brightest star in the constellation Corona Borealis is this one right here, Alphecca, Alphecca Gemma is another name for it, a very old name. So this is where the constellation of Corona Borealis will be. So if you arc to Arcturus to find this bright star, you can see that this star, Corona Borealis, it's almost right under the plough. If you drew a line through the plough and came down pretty much level with Arcturus, a little lower, that'll bring you into the right location. Over here we have Vega, of course, a very bright star, and we can see there it is 0. The magnitude of Vega is 0. Anything brighter than Vega gets a negative number. Anything fainter than Vega gets a bigger number. And we can see back here with Corona Borealis, 2.2. Not incredibly bright, a magnitude of 2, but definitely reasonably bright. It is a little brighter. This is reduced to 12 there. Polaris is pretty close to 2, and we can see that a little bit lower than 2 here for Alphecca. So it's a reasonably bright star. If you find the star Arcturus, you're almost straight under the plough next to Arcturus, in between, a bit closer to Arcturus than Vega over there. And this is all going to be visible here a little after midnight. If I bring up the lines for the constellations, we can see that most of the stars in Corona Borealis, they aren't even visible from here in the city because their magnitude is too low. If we move out into the countryside and get rid of the light pollution, if we go into an incredibly dark sky, you can see down to about magnitude 8. So we can see here now this kind of curved shape of Corona Borealis. It is supposed to look like a crown kind of sitting at an angle. If I bring up the lines again, you can see now that the stars of Corona Borealis are definitely visible. And if I bring up the images, there's Arcturus with his little sickle and his spear or his staff, and there we can see the crown of Corona. Just over there is Hercules, there's Vega in Lyra, and over here we've got Spica in Virgo. So we have a collection of pretty bright stars, Spica and Arcturus and Vega, but Corona Borealis, its brightest star, Alphecca, is just a little bit fainter in there. The star that we're looking for is T Coronae Borealis, and it is a star that is quite faint. It's fainter than anything we can see with the naked eye. Normally, it is about 10 on the magnitude scale. So that's not it. As I say, it is invisible to the naked eye, so it can be a little tricky to find, but I know that it's off the side here somewhere. Luckily, I can search for it using Stellarium's handy search function. As I said, I would be using this a lot in this show. There we go, T Coronae Borealis, not too far off, just over here. And we can see it's been given the name Blaze Star. And that is relating to the fact that it has a nova, a recurrent nova. So this is a double star. There are 2 stars involved here. It brightens up really amazingly or cataclysmically. And this is a nova recurrent. A recurrent nova, one that happens over and over and over again. We can see here that it's magnitude 10. Which makes it barely visible. But, oh, I've clicked onto the wrong star there. When this star does go nova, its magnitude increases up to about 2. So that means that star, which is practically invisible, which is invisible to the naked eye in the countryside, it's going to end up being as bright as the brightest star in its constellation. Give or take, roughly this bright, between about a 3 and a 2 on the magnitude scale. If we move back into the city, and hopefully I can do this without the star deselecting itself, that's good. We'll see where it is, but it's certainly not visible even from a city like Cork. So here we are. It's over in that direction, very close to the brightest star in Coronae Borealis, just a little bit over from this kind of square or rectangle of Hercules here, nearly on a line with Vega through there. So this is where the nova is going to happen, but of course we won't see it until it happens. A recurrent nova happens only with double stars. You need to have a big, massive red giant or a similar massive old star with a small white dwarf orbiting around it. If a white dwarf gets close enough to its massive partner, it will pull over extra material. You'll end up with more and more hydrogen and helium building up around the white dwarf until you have enough for it to fuse. And then suddenly you'll get a load of nuclear fusion, a load of extra light. It will burn through that extra material, and then you'll just have to wait for it to build back up again. There are only a handful of recurrent novae that we get to see regularly, ones that happen in our Milky Way. Luckily, there are other nova that happen, and there is a theory that all novae are recurrent unless they actually blow the star apart, which can happen as well. Just that they take a very long time to recur, 10,000, 100,000 years. Whereas novae like this one recur a little bit more regularly. It was observed brightening up. And before it brightened up, it dimmed. The white dwarf built up material around it, which made it look fainter until that material ignited. Then it looked brighter again. And at the moment, that smaller white dwarf companion is dimming. We're seeing the same kind of dimming we saw before it brightened up the last time. So hopefully up at around September, we'll get to see this nova happening. If you're looking into the northern sky here at around midnight, we've still got the plough. We've certainly got Vega down here at midnight. So we're looking almost in a line with the plough, almost in a line with Vega down here towards Coronae Borealis. The shape of the corona isn't too tricky to see. If you're in the countryside, all of the stars are visible. But again, back in the city, things will be a little bit tougher until you suddenly have this new star in the sky. It's going to be going from an empty space to an extra star, almost that bright, appearing next to it. And this new star, that is where we get the nova from. So that's coming up in the next couple of months, probably. Novae are very hard to predict, but it does look likely we'll get that in the next couple of months, and hopefully you will be nice and prepared to see it. There is a good chance I will talk about it a little once it's happened. Coronae Borealis is up for a really large portion of the night. And these flares, this brightening, this extra release of light, it can last for a couple of days. So hopefully you will get a chance to see it over the next couple of months whenever it actually ends up happening. So here we are a little bit earlier in the evening. There's the Plough Big Dipper, Arc to Arcturus. Over there is Vega, and just in between there is our brightest star in Coronae Borealis. And just down here, a little bit further from it, that's where the extra star is going to brighten up. So if you liked this video, if you enjoyed this kind of content, make sure to like the video so I know, and subscribe to my YouTube channel if you'd like to be kept up to date about the next extraordinary event that's going to be happening in our night sky. If you enjoyed watching this video, you might also enjoy reading about a similar topic on my website, queebeanscontent.ie, and hopefully I'll see you back here next time.